Hi friends, in this video we're gonna see the realization of filters. Okay, basically the filters are of two types, IIR and FIR. We are talking about digital filters, not the analog one. IIR is infinite impulse response filter, whereas FIR is finite impulse response filter. Okay, IIR is a recursive filter. That means this filter function has past, output, present, input, past, input. Okay, whereas finite impulse response filter is non-recursive. That means it has only past input and present input. Now we will see how to realize each filter, okay, individually. Now first coming to IIR filter. Coming to IIR filter, we can realize this filter using so many methods. First method is direct form 1, second method is direct form 2, third method is cascaded form, fourth method is transpose method. Okay, we will see the realization of direct form 1 in this video. The later videos we will see direct form 2, cascaded and transpose methods. Okay, now coming back to direct form 1 method. So basically whenever we write the output equations for a filter, it looks like y of n will be having summation k equal to 0 to n ak y of n minus k plus summation k equal to 0 to m bk x of n minus k. It is the summation of both shifted inputs and shifted outputs. This is my output response. Okay, so here we use, as it is a digital filter, okay, we cannot use Fourier transform or we cannot use other transforms. Rather we use here Z transforms for finding the transfer function. So what is the transfer function? It is h of z, which is given by y of z by x of z, right? So apply Z transforms to the first equation. We have y of z is equal to summation minus k equal to 0 to n ak into y of n minus k. If we apply Z transform, this becomes y of z into z power minus k, right? 0 to m, this becomes bk x of z into z power minus k. Bring the z terms here, y of z terms here. We have 1 plus summation k equal to 0 to n ak into z power minus k 0 to m bk into z power minus k into x of z. If I cross multiply here, I get y of z by x of z. This is equal to 0 to m bk z power minus k by 1 plus summation 0 to n ak z power minus k. Okay, this is what? This is my h of z. This is my filter response in Z transform, right? So whatever may be the transfer function, it will be like numerator by denominator. Whereas numerator indicates zeros, denominator indicates poles. These are my poles, these are my zeros. Right? Now, in the direct form 1, we represent this part of x part is equal to W of n. That means W of n equal to 0 to m bk x of n minus k. Now, if I apply the summation and expand this, I get this terms as up to bm x of n minus m. Right? I get this one. Now, here, what all I required is, I need to multiply this coefficient to x of n. Right? And in between I need adders. Okay? Here it is x of n. Here it is x of n minus 1. Here is x of n minus 2. That means I need delays. Okay? So what are the basic components required for digital filters are delays, adder, multiplier. Right? Now, this thing is over. Next thing is, if this is W of n, what will be my Y of n? It is minus 0 to n ak y of n minus k plus W of n. Right? So, again on expanding this, I get my Y of n is minus of a0 y of n, a1 y of n minus 1 plus up to an y of n minus n plus W of n. Okay, this is my second equation, this is my third equation. I apply for 2 and 3, if you apply Z transforms, okay, to construct the delay filters, to construct this IIR filter, realize this IIR filter, right? Now, this is the concept behind direct form 1. We assume the input to be some W of n and realize the filter for this. After that, you realize the filter for Y of n and you add both of them to get the direct form 1 method of realization of filter. Okay? Now, we consider one example for direct form 1 so that it will be easy for us to understand the realization. Okay, so the example is given as Y of n is equal to 2r cos omega y of n minus 1 minus r square y of n minus 2 plus x of n minus r cos omega naught into x of n minus 1. Okay. Now this is given and they are asked to realize the filter using direct form 1. Okay. So the first step we do is we take this x term and we equate it to W of n. Right? So what will be my W of n? It is x of n minus r cos omega naught into x of n minus 1. Right? Now what should I do? I will take x of n, right, and I need an adder. Okay, my x of n should be delayed by x of n minus 1 times, right? So I need a delay. Here I get x of n minus 1. Okay, now this x of n minus 1 should be multiplied by minus r cos omega and it is given to adder. This will be my W of n. Okay. So this delay this is the delay unit we use. Delays the x of n by one time unit, so it becomes x of n minus 1. Now if I use another delay, it becomes x of n minus 2. Right? Now I am directly giving this one to this. So these both add and give my w of n, which is this one. Okay. Now next thing. This part is over. Now consider y of n. What is y of n? It is 2r cos omega naught y of n minus 1 minus r square y of n minus 2 plus w of n. There is plus w of n is there. So what we need to do is, for this one, first I need to have an adder because I have plus w of n. So w of n is added to what? To y of n. W of n is added to y of n. Right. So next thing is 2r cos omega naught into y of n minus 1. That means my output is getting delayed by one time unit. So I need to have a delay here. This will be giving us y of n minus 1, right? And next thing is I need to multiply by y of n minus 1 with 2r cos omega. 2r cos omega naught. This becomes y of n minus 1 into 2r cos omega. It should be given to here. But I have another term, so I need another adder. Okay. Next thing. Even I have y of n minus 2 term. So I need another delay. This gives my y of n minus 2. Okay. Now I need to multiply it with the minus r square. So this gives my y of n as w of n plus this is y of n minus 1 into 2r cos omega into minus r square into y of n minus 2. This is my y of n. This is my w of n. Now after getting these two figures, we need to add both of them to get overall y of n. Okay, so just adding both the figures. Okay, because we need two adders. From here I am getting my w of n. What is my w of n from this? It is my x of n. Which is delayed by one time unit and is multiplied by minus r cos omega naught, giving my w of n. Whereas this w of n is added with 2r cos omega naught, giving my y of n. I am applying a inverse here, the y of n minus 1, and again apply a delay, which give my y of n minus 2 with an amplitude of constant coefficient of minus 1. Now this is my direct form 1 method realization of the given equation. Okay, so here I use adders, a multiplier, constant multiplier, and a delay units, right? Okay, this is how we realize the given equation y of n in terms of x of n, or in terms of delayed outputs or delayed inputs using direct form 1. The first thing we do is we equate the x of n terms to w of n, and we draw a filter realization, and again for y of n we draw another filter realization. After drawing both of them, we add both of them to get the overall filter realization. In the next video we are going to see how to realize the given filter using direct form 2 method. That's all for this video. Thank you.